Okay, now the last thing we want to do is we want to talk about the number of subsets. And so I'm going to create original sets that contain the number of elements. I'm going to kind of slip that in here. Okay, so I started out with a set that the original set contained no elements, so that's the empty set. The only subset is the set itself, so there's one subset. Number of elements in the second set is 1. It has two subsets. Remember, the empty set is a subset of every set. So we have that, and then we have the set itself. So we have two subsets. Okay, when we look at 1 and 2, that's 2 elements. We have the empty set with no elements. We have 2 sets with 1 element, and then we have the original set. So we have 4 subsets. Now when we get to 3 elements, it gets a little more complicated. We have 1 subset with 0 elements, and that should be, we have 3 subsets with 1 element, and we have 1, 2, 3 with 2 elements, and then we have the set itself. So we ended up with 1, 2, 3, 4, 5, 6, 7, 8 subsets for that one. So my next question is, how many subsets will we have for a set that contains 4 elements? Well, we'll do this one together. Let's see, we have no elements. We have 1 element at a time. Okay, now we want to do them in pairs. We can have a 1 and a 2, a 1 and a 3, a 1 and a 4, a 2 and a 3, a 2 and a 4. Okay, and a 3 and a 4. Okay, now we can go to 3. We can have 1, 2, 3, 1, 2, 4, and 2, 3, 4, and 1, 2, 3, 4. Okay, so anybody want to, let's see, how many do you think there might be? Most people knows the pattern is doubling, so a guess of 16. Let's see if we have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. We should have 16, so I'm missing one somewhere. 1, 2, 4. Ah, I see it. I should have a 1, 3, 4. Okay, so we do have 16. Alright, so the question is, what is the pattern? If I have n elements in my set, how many subsets will I have? Well, if you look at the number of elements in the set, each of those is a power of 2. So 1 is to the 0. Remember, 0, any number to the 0 power is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. So the question is, when you have n elements, how many subsets are you going to have? You're going to have 2 to the n. So that's the important formula that you want to remember from this exercise. And so next I ask a specific question. We have 6 elements. It's going to be 2 to the 6th, which I think turns out to be 64. So that's the number of subsets. Now the next question has to do with the number of proper subsets. Well, we have to eliminate the set itself all the way down. we're talking about proper subsets, so here it's that one. So it's going to be 1 minus 1 is going to be 0. 2 minus 1 is going to give us 1. Now we're going to have 4 minus 1 is 3. 8 minus 1 is 7. 15. And this in general, the general case is going to be 2 to the n. And we find that and then subtract 1. So in this case we would have 63 proper subsets. Okay, and we talked about the Aleph null in the last lecture, so I'm not going to go over that again. Okay, so again, your next step will be to watch the sample problems for section 2.2, and then from there you'll be ready to go on to the